This video deals with the method of elimination, which is the second technique for solving linear equations in two variables. So in other words, you can use the method of elimination to solve simultaneous equations, just like you can use the method of substitution. So here is a system of two equations in two variables, equation 1 and equation 2. And the first step in the method of elimination is to choose a variable. So I'm just going to choose the variable x. I'll just make a point that the variable you choose determines how easy your whole simplification of the problem will be. But at this point in time, since this is just the first time you're being introduced to the method of elimination, we're just going to choose variables randomly and hope that the problem doesn't get too complicated. So we're going to choose the variable x. Fine. Step 1 is done. The next step says ensure that the coefficients of the chosen variable have the same magnitude in both equations. So what does that mean? Well, when two numbers have the same magnitude, they have the same value if you ignore their signs. So this is plus 2 and minus 2. If you ignore their signs, you're just left with 2 and you're just left with 2. So the magnitude of plus 2 is 2. You just ignore its sign. The magnitude of minus 2 is 2 as well. When two numbers have the same magnitude, they are the same if you ignore their signs. You see what I'm saying here? Give another example. You have the number 4 and minus 4. The magnitude of 4 or plus 4, magnitude of plus 4 is 4. The magnitude of minus 4 is 4. Because all you're doing is ignoring the signs. When two numbers have the same magnitude, they have the same value when you ignore the signs. Very easy concept. So we need to ensure that the coefficients of the chosen variable have the same magnitude in both equations. Coefficient of x in equation 1 is 5. The coefficient of x in equation 2 is minus 5. So the coefficients of x have the same magnitude because the magnitude of 5 is 5. The magnitude of minus 5 is also 5. So step 2 has been met as well. So now to the final step, step 3. Final step says eliminate the chosen variable via any appropriate operation. So we need to eliminate the chosen variable. Here we've chosen x, so we need to eliminate the variable x. This is the method of elimination. We're eliminating a variable. Okay, what does that mean? We'll get to that shortly. What's our appropriate operations? We'll also get to that shortly. Now we have two equations. We want to eliminate x. We don't want x to appear, so we want to get an equation that doesn't involve x. So we're going to reduce these two equations to one equation that doesn't involve x. So basically go from equations in two variables to an equation in just one variable. So let's do something. Let's add equation 1 and equation 2. When you add the left hand sides of both equations, you get 5x plus y plus the left hand side of equation 2 minus 5x plus 3y equals to, when you add the right hand side of both equations, you get 6 plus minus 2. When you simplify this, you get, or you drop the brackets rather, you get 5x plus y plus minus 5x plus 3y. Or rather, plus times minus 5x is minus 5x, plus times plus 3y is plus 3y. 6 plus minus 2 is 4. Rearranging this, bringing all like terms together, 5x minus 5x plus y plus 3y equals 4. Simplifying the left hand side gives, well, this cancels out to 0. Y plus 3y is 4y, is equal to 4. Dividing through by 4 gives y equals 1. So I've just made y the subject of the formula. Now we know that y is 1. So in order to determine x, what do? Well, we go to any equation involving x and y. So this or this, and we determine x. So going back to equation 1, which is 5x plus y equals 6. You can replace y with 1 because y is 1. So anywhere you see y, you can replace it with 1. Replace y with 1 in equation 1. And doing so gives 5x plus y equals 6. Making x a subject of formula gives 5x equals 5, x equals 1. Because all I've done is subtract 1 from both sides and divide through by 5. So now we know that x is 1 and y is also 1. So just going back to the third step. Third step says eliminate the chosen variable via any appropriate operation. And the operation I was chosen was the addition operation. On the equations, we're actually adding equations. Equation 1 was added to equation 2. Why? Because the way you add equations is to add the left-hand side terms, which is what we did on this side. You add the left-hand side terms, and you also add the right-hand side terms, and you equate them. Very simple. When you add two equations, or let's even go back, you note that an equation has a left-hand side and a right-hand side. So when you add two equations together, you add their left-hand side terms together, and you add their right-hand side terms together, then you equate them. That's all. Why do we choose addition as the appropriate operation? Well, we want to eliminate the variable x. We don't want it to appear in this equation. If you add equation 1 to equation 2, you'll be adding 5x to minus 5x. So think of adding 5x to minus 5x. 5x plus minus 5x is the same thing as 5x minus 5x, which means you get 0. So you get rid of the 5x. Y plus 3y is 4y. So y remains, and 6 plus minus 2 is 4. So that's all we've done here. So it's pretty much what we've done here. Another way to do this is to just say, well, I'm going to add both equations to each other. 5x plus minus 5x is 0. Y plus 3y is 4y equals 6 plus minus 2 is 4. That's another way to go about it, and you get the same result. But the approach I showed earlier is more systematic, and you're less likely to make mistakes if you use this method. So we just added the two equations. We added the left-hand side terms, we added the right-hand side terms, and we equated them to each other, the result to each other. We simplified to get 4y equals 4. We determined that y is equal to 1. Now we have a value of one of the variables, because you remember we're trying to find a value of x and a value of y that satisfy the original equations. And using this value of y, we determine the value of x by replacing this result. So replacing y with 1 in any equation involving x and y, because doing so gives an equation just in terms of x. So this is an equation in terms of x and y, equation 1. Replacing y with 1 gets rid of the variable y, and we're just left with one variable, the variable x. And now we can just make x a subject of the formula to determine the value of x. So now we know that y is 1 and x is also 1. That's the method of elimination. So here's another example. We have an equation 1, and you have an equation 2. Two equations, two variables. What's the first step? Choose a variable. So I'm going to choose the variable x. And second step says ensure that the coefficients of the chosen variable, ensure that the coefficients of x have the same magnitude in both equations. In equation 1, the coefficient of x has a magnitude of 2. 2 has a magnitude of 2. The coefficient of x in equation 2, which is 2, also has a magnitude of 2. So this step has been satisfied as well. So the third step, eliminate the chosen variable via any appropriate operation. So what can we do to these two equations to get rid of the variable x, or rather, what operation can we carry out with both equations to get rid of the variable x? So we can just have an equation involving one variable, which is very easy to solve. Well, if you subtract equation 2 from 1 or 1 from 2, we can get rid of x. Why? Because you have a 2x here and a 2x here. 2x minus 2x is 0. Equation 1 minus equation 2. To eliminate x, the left hand side subtraction is as follows: 2x plus 6y is 2x plus 6y minus, because we're subtracting equation 2 from 1, so 1 minus equation 1 minus equation 2, so 2x plus 6y minus 2x minus y. Don't forget the brackets, very important. And the right hand side subtraction is 18 minus 4, 18 minus 4. So we equate the result of the left hand side subtraction to the result of the right hand side subtraction. Simplifying gives the following. Drop in the bracket, we have this minus times 2x minus 2x minus times minus y plus y. 18 minus 4 is 14. Rearranging by bringing like terms together gives following. 2x minus 2x is 0, so that cancels out. 6y plus y is 7y equals to 14. Now we can easily determine y by making y the subject. So dividing through by 7 gives y equals 14 over 7, which is 2. So we now know what y is. Now to determine x. What is x? Well, we can replace y with 2 in any equation involving both x and y. So say we replace y with 2 in equation 2. Equation 2 is 2x minus y equals 4. So replacing, so this is equation 2. Replacing y with 2 in equation 2 gives the following. 2x minus y is 2, equals 4. Making x subject to a formula will allow us to determine a value for x. So adding 2 to both sides gives 2x equals 6. Dividing through by 2 gives x equals 3. So now we know that x is 3 and y is 2. And we're done. That's the method of elimination. Very easy. Just note that the key thing here was in determining the appropriate operation. Because the coefficients had the same value, coefficient of x had the same value, we could easily subtract one equation from the other to eliminate the chosen variable. What I'm going to do is I'm going to run through another example, and then I'm going to tell you how you determine what operation to carry out with the two equations. Here's another system of two equations, two variables, and the method of elimination is going to be applied. So equation 1 and equation 2. First step is to choose a variable. This time we're just going to choose variable y. The second step is to ensure that the coefficients of the chosen variable have the same magnitude in both equations. In equation 1, what's the magnitude of the variable y? It's 1. You can imagine a 1 being here just in front of the y, because 1 times y is y. So we have 1 as the coefficient in equation 1. So I'm just going to write coefficients of y. In equation 1, the coefficient of y is 1. In equation 2, the coefficient of y is 16. The magnitude of 1 is 1, the magnitude of 16 is 16. But they don't have the same magnitude. So what can I do to ensure that the magnitudes of y are the same in both equations? Well, what you do is you multiply the coefficients by each other. So if I multiply 1 by 16, I get 16. If I multiply 16 by the other coefficient 1, I also get 16. So all of a sudden, we now have a situation where the coefficients are the same. But to achieve this, you have to multiply equation 1 through by 16 and equation 2 through by 1. So you multiply equation 1 by the coefficient of y in equation 2, and you multiply equation 2 by the coefficient of y in equation 1. So doing so gives equation 1 times 16 gives 32x plus 16y equals 3 times 16, which is 48. And then equation 2 times 1 is 16x is unchanged. Anytime you multiply 1 by anything, nothing changes. So now we have equation 3 and equation 4. In these equations, the coefficients of the chosen variable have the same magnitudes. Coefficient of y here is 16, which has a magnitude of 16. The coefficient of y here has a magnitude of 16 as well. So this step has been met. The coefficients of the chosen variable have the same magnitude. So I'm just going to focus on equation 3 and 4 now. We're going to forget about 1 and 2 for now. Now we need to eliminate the chosen variable via any appropriate operation. So let me just write the equations we're dealing with now clearly. 32x plus 16y. Equation 3. To eliminate the chosen variable, so to eliminate y, just observe the two equations. In equation 3, the coefficient of y is 16. In equation 4, the coefficient of y is 16. Since the coefficients are the same, you carry out a subtraction. So equation 3 minus equation 4 will cause y to be eliminated. We'll give an equation in which y doesn't appear. So let's do the left hand side subtraction. Left hand side of equation 3 is 32x plus 16y. So minus the left hand side of equation 4 is 16x plus 16y equals to right hand side of equation 3, 48, minus the right hand side of equation 4, 32. Now we just simplify and we get an equation in which y doesn't appear. Dropping the brackets gives 32x plus 16y minus times 16x is minus 16x, minus times plus 16y is minus 16y. 48 minus 32 is 16. So rearranging to bring the like terms together on this side gives so simplifying 32x minus 16x is what? 16x. 16y minus 6y is 0, so there's no need to write that. So equals to 16. So we have x is equal to 1 when you divide through by 16. So we now know what x is. So now to determine y, the value of y that satisfies the equation when x is 1, we replace x with 1 in any equation that involves x and y. So in 3 or 4 or even 1 and 2. So I'm going to choose equation 1, which is a simpler equation than this equation because this involves bigger numbers. We have 32, 16, 48, 16, 16, 32. Here we have numbers like 2, 1, and 3. So we're going to choose equation 1, which is 2x plus y equals 3. Equation 1 is 2x plus y equals 3. So what I'm going to do is I'm going to basically use this result to get y. So I'm going to replace x with 1 in equation 1. Doing so gives 2 times x, 2 times 1, plus y equals 3. 2 plus y equals 3. Making y the subject of the formula by subtracting 2 from both sides gives y equals 3 minus 2, 1. So in this case we have x is equal to 1 and y is equal to 1 as the results obtained by the method of elimination. And if you replace these results, x equals 1 and y equals 1, into the original equations, you'll find that both equations are satisfied. So here's another example. Same thing, two equations with two variables. Here the variables are x and z. You need to ensure that the coefficients of the chosen variable have the same magnitude in both equations. But for this rule to hold, you must be writing the variables must appear on the same side of the equation. So I'll give you an example. Say we choose variable z. We choose variable z. In the first equation, z appears on the right hand side. In the second equation, z appears on the left hand side. So you need to ensure that, or you need to rewrite the equation such that z appears on the same side in both equations. So we can rewrite equation 1 by swapping the left hand side and right hand side to give 2z minus x equals 8, so that z appears on the left hand side. In the second equation, z appears on the left hand side, so it's fine. So now you can then say, okay, let me ensure that in both equations, so this is the same thing as equation 1, in both equations the coefficients of z have the same magnitudes. To do that, you have to ensure that the equations appear on the same side. So in this case, the coefficient of z is 2, which has a magnitude of 2. The coefficient of z here is 3, which has a magnitude of 2. So in order to eliminate z, which is what the third step requires us to do, we need to first ensure that the coefficient of z in both equations has the same magnitude, and this can be achieved by multiplying equation 1 by the magnitude of z in the second equation, which is 3, and multiplying equation 2 through by the coefficient of z in the first equation. So in case I didn't say this right, you multiply equation 1 through by the coefficient of z in the second equation, and you multiply equation 2 through by the coefficient of z in the first equation. This way we get equations with the same magnitude, as you see. Multiplying equation 1 through by 3 gives 6z minus 3x equals 3 times 8, which is 24. So all you do is just multiply each term by 3. 3 times 2z, 6z, minus 3 times x, 3x, equals to 3 times 8, 24. So this gives us equation 3. Similarly, multiplying equation 2 through by 2, you multiply each term by 2. So 3z times 2 is 6z, 2 times 9 is 18, 2 times 2x is 4x. So now, as you can see, we have two equations, and now the coefficient of z in both equations has the same magnitude. The magnitude of the coefficient of z here is 6. Or let me put it this way, the coefficient of z here is 6, which has a magnitude of 6. The coefficient of z here is 6, which has a magnitude of 6, which they are the same. So we can proceed to the third step, which says eliminate the chosen variable. Now, our chosen variable is z, and the coefficients actually are the same. So what we do is subtract one equation from the other to eliminate z. So I'm going to do equation 3 minus equation 4. And this gives, well, if you do the left hand side subtraction, you have 6z minus 3x minus 6z. So the left hand side of equation 3 minus the left hand side of equation 4, and you equate that to the result of subtracting the right hand side of equation 3, or not subtracting, but saying the right hand side of equation 3 minus the right hand side of equation 4. So it is a subtraction. Dropping the brackets gives 6z minus 3x minus 6z, which equals to 24 minus, so minus times 18, minus 18, minus times plus 4x is minus 4x. And simplifying, well, rearranging, we get 6z minus 6z minus 3x. 24 minus 18 is 6 minus 4x. So this is minus 3x equals 6 minus 4x. So we want to make x a subject of formula. Let's isolate x on the left hand side. So add 4x to both sides. And this gives minus 3x plus 4x equals to 6 minus 4x plus 4x. So you do the same thing to the left hand side as you do to the right hand side, and this gives x, this gives 6. So x is 6. So what about y? Well, we use this result in any equation involving both x and y. We go to equation 1, which is 8 equals 2z minus x. So sorry, no y. The other variable in this case is z. So we go to equation 1, which is 8 equals 2z minus x. Replacing our result, x equals 6. Gives 8 equals 2z minus 6. So in order to make x a subject of formula, we need to take z to the left hand side. So let's swap the left hand side and right hand side. So I'm just going to write that down. Swap and this gives 2z minus 6 equals 8. So let's get rid of this minus 6 so that we can just have the term involving z. Adding 6 to both sides gives 2z equals 14. Finally, dividing through by 2 gives z equals 7. So we have that x is 6 and z is 7. Substituting this result into the original equations will show you that they are valid because the equations will be satisfied. So let's try here. In equation 1, the left hand side is 8. The right hand side is 2z minus x. Our z is 7, so 2 times 7 is 14. Our x is 6. 14 minus 6 is 8. So our right hand side is equal to the left hand side when z is 7 and x is 6. So there you go with the method of elimination.